The National Eligibility Cum-Entrance Test, or NEET, is a gateway for aspiring medical professionals in India. It's, a challenging exam that demands a thorough understanding of various subjects, including chemistry. Inorganic chemistry might seem daunting but plays a crucial role in NEET. It forms the foundation for understanding biological processes and the chemical reactions within living organisms. A good grasp of inorganic chemistry is essential for tackling questions related to bioinorganic chemistry, pharmaceutical chemistry, and more. Inorganic chemistry explores the behavior and properties of elements and their compounds, excluding most carbon-containing compounds. It delves into the periodic table, chemical bonding, and the characteristics of various elements and their compounds. Mastering inorganic chemistry equips NEET aspirants with a strong base for understanding the complex chemistry of life. This understanding is vital for excelling in medical studies and future careers in healthcare. The periodic table is the heart of chemistry, providing a systematic arrangement of all known elements. Dmitri Mendeleev's periodic table revolutionized how we study elements. It groups elements with similar properties, making it easier to predict their behavior. The modern periodic table is based on atomic number, which represents the number of protons in an atom's nucleus. This arrangement reveals periodic trends, patterns in the properties of elements across periods and down groups. Understanding electronic configuration is key to explaining these trends. The electronic configuration of an atom describes the arrangement of electrons in its various energy levels or orbitals. Trends like atomic size, ionization energy, electron affinity, and electronegativity exhibit periodicity. Atomic size generally increases down a group and decreases across a period. Ionization energy, the energy required to remove an electron from an atom, shows the opposite trend. These trends are crucial for understanding chemical bonding and reactivity, forming the basis for predicting how elements will interact. Metals hold immense importance in our daily lives, from construction and transportation to electronics and medicine. Metallurgy, the science of extracting metals from their ores and refining them, is a crucial aspect of inorganic chemistry. Metals are rarely found in their pure form in nature. They occur as minerals in combination with other elements in the form of ores. The process of extracting metals from ores and refining them involves several steps: mining, concentration of ores, extraction of crude metal from concentrated ore, and refining of the extracted metal. Different metals require different extraction methods based on their reactivity. For example, highly reactive metals like sodium and aluminum are extracted using electrolysis, while less reactive metals like copper can be extracted by roasting their sulfide ores. Hydrogen, the lightest and most abundant element in the universe, holds a unique position in the periodic table. It's placed in group 1 with alkali metals due to its single valence electron, but also exhibits similarities with halogens in some aspects. Hydrogen exists as 3 isotopes, protium, deuterium, and tritium, each with varying numbers of neutrons. Hydrogen plays a vital role in various industrial processes, including the production of ammonia, methanol, and refining petroleum. It's a clean fuel source and a key player in fuel cell technology, offering a promising avenue for a sustainable energy future. Understanding hydrogen's properties, isotopes, and applications is essential for NEET aspirants as it connects various concepts in chemistry. Section 5. Exploring the S-block alkali and alkaline earth metals. The S-block elements, located on the left side of the periodic table, comprise alkali metals, which are in group 1, and alkaline earth metals, which are in group 2. These metals are highly reactive due to their single, in the case of alkali metals, or 2, in the case of alkaline earth metals, valence electrons, which they readily lose to achieve a stable electronic configuration. Alkali metals, like sodium and potassium, are soft, silvery white metals that react violently with water, producing hydrogen gas. On the other hand, alkaline earth metals, such as magnesium and calcium, are harder and less reactive than alkali metals. They are essential components of various biological molecules and play vital roles in biological processes. Understanding the trends in their reactivity, the solubility of their compounds, and their importance in biological systems is crucial for NEET. Section 6. Delving into the P-block properties and applications. The P-block elements, occupying groups 13 to 18 of the periodic table, display a wide range of properties and play diverse roles in various fields. This block includes nonmetals, metalloids, and metals, showcasing the fascinating diversity in the periodic table. Carbon, the backbone of life, is a key P-block element. Nitrogen, a crucial component of proteins and nucleic acids, is another significant element in this block. Oxygen, essential for respiration, also resides in the P-block. Halogens, which are in group 17, are highly reactive nonmetals used in disinfectants and water purification. The noble gases, which are in group 18, are known for their inertness and find applications in lighting and lasers. Understanding the unique characteristics of each group and their significance is crucial for NEET aspirants. Section 7. Navigating the D and F block transition and intertransition metals. The D block elements, located in the central region of the periodic table, are known as transition metals. They are characterized by their partially filled d orbitals, which give them unique properties such as variable oxidation states and the ability to form colorful compounds. Transition metals, such as iron, copper, and zinc, play vital roles in biological systems. Iron, a component of hemoglobin, is crucial for oxygen transport in the blood. The F block elements, located at the bottom of the periodic table, consist of lanthanides and actinides. They are characterized by their partially filled F orbitals, and are often referred to as inner transition metals. Understanding their electronic configurations, properties, and applications is crucial for NEET. Section 8. Coordination compounds, a symphony of elements. Coordination compounds, also known as complex compounds, are formed by the association of a central metal atom or ion with a surrounding array of molecules or ions called ligands. These compounds are characterized by their intricate structures and unique properties. Werner's theory laid the foundation for understanding the bonding in coordination compounds. Valence bond theory and crystal field theory provide further insights into the nature of bonding in these compounds. Isomerism, a phenomenon where compounds with the same molecular formula have different structural arrangements, is an important aspect of coordination chemistry. Section 9. Environmental chemistry. Chemistry for a sustainable future. Environmental chemistry explores the chemical processes occurring in the environment, both natural and man-made. It examines the sources, reactions, transport, effects, and fates of chemical species in the air, water, and soil. Understanding environmental chemistry is crucial for addressing environmental challenges such as pollution, climate change, and ozone layer depletion. It helps us develop sustainable practices, reduce our environmental footprint, and preserve the planet for future generations. Topics like air and water pollution, greenhouse gases, and acid rain fall under this umbrella. Section 10. Conquering NEET, Inorganic Chemistry, a recap. Mastering inorganic chemistry is not just about memorizing facts and figures. It's about understanding the underlying principles and applying them to solve problems. A deep understanding of the periodic table, chemical bonding, and the properties of elements and their compounds is crucial for excelling in NEET inorganic chemistry. Regular practice, solving previous year's question papers, and focusing on conceptual clarity are key to success. Remember, consistent effort and a strategic approach can help you conquer NEET inorganic chemistry and pave your way to a rewarding career in medicine.